Hello all dear students, I welcome you all in the series by Made Easy. So in this series, let us discuss the next question from the previous year GATE exam. This question was asked in the year 2006 in GATE instrumentation paper. So let's read the question first to understand the concept. We will discuss something and then after the concept we will solve the question. So what is the question? A unity feedback system has the following open loop frequency response. So let us consider open loop transfer function. Let us consider open loop transfer function, that is nothing but what? GS into HS. So definitely examiner has given us the magnitude response as well as the phase response, Examiner has given us magnitude response as well as the phase response with respect to the different frequency in the table. Examiner want to know the gain and phase margin. Examiner want to know the gain margin and examiner want to know the phase margin. With respect to the gain margin and phase margin, in all the competitive examinations like GATE examination, like engineering services examination, like in civil services means examination as well, examiner has asked many times the question. So to understand the gain margin and phase margin concept with respect to their corresponding frequencies, that is nothing but phase crossover frequency and gain crossover frequency, I want to discuss something here in a proper way. This is nothing but with respect to the Bode plot and this is nothing but with respect to the polar plot. I want to tell you what is the gain crossover frequency, what is the phase crossover frequency. This is a unit radius circle. Let us consider this is the yellow colored polar plot of any open loop control system. This is the polar plot. So the magnitude, if unity at any particular frequency, magnitude of open loop system gain is unity at particular frequency, then that frequency can be called as gain crossover frequency. The phase of open loop system at any frequency is equal to what? Minus 180 degree, then that frequency can be considered as what? Phase crossover frequency. So if the radius of the circle is 1, so definitely it will be what? Minus 1. I want to mark this magnitude. Up to the negative real axis going to cut by the polar plot. I want to mark this as x. So what will be the gain margin? The gain margin can be in this way. This can be the gain margin. But if you want to calculate in dB, you must take care. When we are going to solve the question, at that moment I will tell you. Now, what is the phase margin? This is nothing but phi. With respect to the frequency, the gain is equal to 1. At what frequency? At gain crossover frequency. What is the gain? 1, but the phase is nothing but phi. This rest part can be introduced in terms of phase margin. Roughly I am telling. So what will be the gain margin? The gain margin in dB will be equal to minus 20 log 10 x. What is x? The magnitude of open loop system gain at the phase crossover frequency. Means where x is nothing but what? Magnitude Gj omega Pc into Hj omega Pc. This is nothing but the value of x. Now what is phase margin? this is nothing but the phase margin I have introduced clearly. So how can you calculate it? You can calculate by the equation 180 plus 5. Sir, why plus 5? Why not minus 5? Because 5 is itself negative value you can observe. So this is nothing but your gain margin. This is nothing but your phase margin. Phi is nothing but, where phi is nothing but phase at gain crossover frequency. At gain crossover frequency. This is the information now I have written here. The information I have introduced with respect to a polar plot. But sir, the question is something with respect to frequency response. So I want to take one more example to introduce something. This is nothing but the magnitude plot. Here this is nothing but the frequency axis, omega axis, or we can say it will be a logarithmic scale axis. Here I can say in a similar way. So this is the Bode magnitude plot of any other particular system. This is the phase plot of any other particular system. So the magnitude plot is in dB. So definitely here we are not going to mark the point where the magnitude is unity like that we have marked here. We will mark the point where the magnitude is 0 dB. So the frequency at which the magnitude is 0 dB is nothing but what? Is our gain crossover frequency. This is nothing but what? Our gain crossover frequency I have clearly marked here. And with respect to that omega GC, what we are going to calculate? We are going to calculate the phase at that particular frequency, that is known as phi. If you will get that phi, simply you will add with plus 180 degree, you will get phase margin. Now come to the next point. The phase plot I have. The frequency at which the phase is equal to minus 180 degree, that particular frequency can be considered as what? Phase crossover frequency. And at that phase crossover frequency, whatever be the magnitude is going to help us in the calculation of gain margin. But here it is what? In dB. So what we are going to introduce? This is nothing but in dB. So we can say the gain margin will be equal to 0 minus that dB value here. Whatever be the dB value, what is the dB value here? Minus x. So you have to take care and you have to introduce 0 minus x, then you will get what? Plus x dB as the gain margin. This much information now you have, and with respect to this much information, the concept gain margin, phase margin, gain crossover frequency, phase crossover frequency, now we want to hit the particular question. So let's discuss this question now when we have the concept with us. So directly I am going to solve here. Okay. So first of all, I want to calculate the gain margin, and as the values are not in dB, they are in magnitude. So the x we are going to get, they are in magnitude. So x we are going to get. So we will use this formula. If the examiner has given the information of magnitude in dB, then we will proceed in that way. So what? Gain margin is nothing but minus 20 log 10 x minus 20 log 10 x, and x is nothing but the magnitude at the phase crossover frequency, and the phase crossover frequency is nothing but the frequency where the phase is nothing but what? Minus 180 degree. So this is nothing but our x. So I will write here minus 20 log 10. What is x? X is nothing but what? 0.64. So from here we are going to calculate and we are going to get 3.88 dB. We will get this value. So this is nothing but our gain margin. This is nothing but our gain margin. This is nothing but our gain margin. Now what about the phase margin? What about the phase margin? Phase margin is nothing but 180 plus phi. What is phi? Phi is nothing but, from here you can say, phi is nothing but the phase at omega gc. Whatever be the phase at omega gc, that is nothing but phi. As it is, we are going to take that value. And if you are observing, phi is nothing but at omega gc, and omega gc is nothing but the frequency when the magnitude is 1. So whenever the magnitude is 1, that is nothing but going to with respect to omega gc. Whenever there is the magnitude 0 dB, means actual magnitude is 1 at that particular instant, whatever with the phi, wherever the magnitude is equal to 1, at that instant phi is nothing but minus 170 degree, clearly given to us. So in place of phi, I am directly writing what? Minus 170 degree. So what we are getting? We are getting here 10 degree. Like that, it is nothing but phase margin. So if you are going to cross check the option, in the option, the D 3.88 dB is nothing but our gain margin, and plus 10 degree, not minus 10 degree, plus 10 degree, because 180 minus 170 is nothing but what? Plus 10 degree is nothing but our phase margin. So like this, the answer of this particular question is nothing but D. The gain crossover frequency, the phase crossover frequency, the gain margin, the phase margin, if you can imagine in this way, then definitely you can never forget the relation between them, either if the concept is with respect to actual magnitude or if the concept is with respect to the magnitude in dB. If you have the clear information and you can imagine the things in your mind, definitely you are going to hit the particular question within second, and the answer will be definitely with proper confidence. Thank you.